Hello, pre-calc. I have a document online that if you would like to follow along with, you can definitely do that. This is going to be like an intro to all the things you need to know about Desmos, and then also a really quick lesson on conic sections. And when I say really quick, I truly mean I'm just going to give you the formulas. So we're going to start. I'm actually not going to do everything on this because realistically, I mean, you can type the line y equals x and be so excited like, yes, it's a line, great. I'm going to show you a couple things though just with this line. If you click here for the edit, this is where you'd be able to change the color of your line and obviously the style. So if it's dotted or dashed. Oops, I did not mean to delete that. That's fine. Okay, I'm actually going to skip steps 1 through 5. I'm going to start just by making a circle. So x squared, you can do squared by, I am typing the up arrow, which is like shift and 6. So x squared plus y squared is equal to 1. We've got a circle here. Very beautiful little circle. If I want to change the center, so this is, I guess, the first small bit of the conic section, I'm going to change its location. So now we have a center at 4, 0. Or if I want to make it, let's go with 4, 4. Oops. 4, 4. I'm going to say y minus 4. And now I have a circle centered at 4, 4. If I want to change the radius, I can just make it bigger. So there we go. And realistically, you guys can type in equations. That's not what I want us to look at. I want to just look at a piece of this circle. So what if I don't really want the whole thing to show up? So let's talk about restrictions. Technically, this is step 9 here. And so we are going to limit this graph to only see, let's go with the top half. So if I really just want the top half to show up, I want to make sure I am setting my limitations on either my x or my y. So if I want to just see the top half, I want to restrict the y values. So I'm going to add in these funky little bracket parentheses, and I'm going to say I want my y values to be between 4 and, it doesn't really matter, I guess it would be 4, 5, 6, 7, 8. So let's go is less than or equal to 9. And so now I only have the top half of that circle showing up. If I had changed these to my x values, only the right side would change, and you can play around with this to get just a piece of your graph to show up. So that's one thing I wanted to mention. If you want to change the color, we already talked about that. Okay, so that's 10. Let's see. Ooh, yeah, let's do some shading. So what if I change this instead of equal to, what if I do less than? Notice that it is shaded inside that circle, and because it's strictly less than, it's got a dotted line. If I add the equal sign, oops, right after that, it's going to be less than or equal to, so it keeps that. And notice because we have these restrictions, it does not shade for the entire circle. Okay, let's continue with this restricting business, and I'm actually going to hide this circle for right now. So let's say I have the line y is equal to, what is it on here, 3x plus 2. And it's this beautiful line, but, oops, I said 3x plus 2. Okay, but what if I only want the values between 1 and 5 to show up? So we restrict, oops, I did not mean to do that twice. We're restricting our x's to be only from 1 to 5. I could also change this to be from, what would be this? From 5 on the y to about, what is it, 16 or so on the y. So you can do either in terms of x or y for restrictions. And actually, why don't we just, I'll show you that. What if I do it again, but instead of restricting the x's, let's change my y's. And what did I say? From 5 to 17. Notice how these two lines right now, these line segments, are exactly the same. They are just restricting different pieces. So for this purple version, I am technically cutting it in terms of our x. In this black line, I am cutting it in terms of the y. Okay, so that's great just to mention. What then happens if we shade a restricted line? So if I take, I'm going to get rid of that one, and if I change this to be greater than or equal to, so it's got this lovely shading all above it, but what if I don't want all that shading? What if I really only want it to go, let's say, to this part? What if I want this like shaded triangle, let's say? So I'm going to cap it on this other side by, what value was that? Like 17? And so now what I'm saying is I want my graph y is greater than or equal to 3x plus 2 to be shaded above, but I want to stop it. Ooh, I want this to be greater than or equal to. I want to stop it at 17. I could do higher. I could do 20 or 120. I could do 20 and then we've got this whole business, or I could do less. I could do maybe 14, and I'm restricting then both the shading and the segment. What else can I show you? Now let's talk. We're going to just take a couple really quick notes. Like I said, this is truly going to be like a crash course in these equations because if I'm being honest, you don't need them all that much in calculus. So we know we're going to start with our circle. We know the equation for a circle. We already looked at it. Is x minus h squared plus y minus k squared is equal to r squared, where hk is the center and r, of course, is our radius. So we already saw a circle. I did that here, except it's obviously shaded. And we'll do parabola next because that's the other one that we know and love already. So back to this parabola. Remember, there's a ton of different versions of the form of a parabola, so you can write it in a lot of different ways. I'm going to say if I have a parabola, let's go y is equal to a times x minus h squared plus k, where hk is going to be the vertex. And of course, a is going to tell us if it opens up, and here's our vertex hk, or if it opens down. The next two are going to be slightly new, even though we have seen them before, but I will graph these. So we're going to start with an ellipse. An ellipse is essentially an oval, and so it's going to look very similar to a circle would, but with a slight difference. So an ellipse will be x minus h squared over some value a plus y minus k squared over some value b is equal to 1. So I'm going to take this right now and I'm going to show you a graph. Let's go with Desmos. Okay. So x minus, let's go x minus 5 squared. Squared all over 4, we'll say, plus, I'm actually going to just copy this and make that a y. And we'll change this to 8, and then I'll show you kind of what's going on, is equal to 1. Okay, so here is our ellipse that I just made up. I didn't make this any specific value for any reason. But notice a couple things. The center is 5, 5, so we see that, 5, 5, these pieces right here. And then notice, in this ellipse, it is a lot bigger vertically, because our denominator on the y is bigger than the denominator on the x. Let's say I change these really quick to 2 and 4. Okay, so now the denominator of our x variable is bigger than the denominator of our y variable, so it is wider. So that's how we're going to change. We can make it super big or whatever we want. We've got this beautiful ellipse. Da-da-da! All right, and then the other graph we want to look at is, where's my pen? A hyperbola. which is a very similar form to our ellipse, but has one major difference. So it's x minus h. Oh, hold on. I want to go back. Technically, this is a squared and b squared, and to be honest, the number down here doesn't really matter. There's kind of a lot that ellipses and hyperbolas have that we're not going to talk about. For example, an ellipse have these little pieces right here and right here. It's basically got this, like, they're called foci. I think you pronounce it like that. But they're these like focus points that are equidistant from all these different pieces. And you know what? At this point, it's not worth doing everything, so I just want you to graph something that looks cool. That's what we're going to work on. Okay, so back to our hyperbola. Where was I? All right, hyperbola. X minus h quantity squared all over a squared minus y minus k squared all over b squared is equal to 1. So notice the big difference here is a plus sign and a minus sign. So if I graph something, I've got that beautiful guy. Let's do x plus this time 2 squared. This is all over, let's say, 10. Or no, we'll make it different. We'll make it 9. Minus, and then we've got y plus 4 squared all over, we need the squared, all over, let's go 3 equals 1. So here's what we got. This is a hyperbola. Notice that it's not a shape that has a center per se, but if we go to the point, and if you want to just plot a point, -2, -4, that point, notice this -2, -4, is this center, kind of the midpoint right here of these branches of our hyperbola. If we wanted to restrict this thing, maybe just make half of it show up, we would do the same restrictions that we kind of looked at before. So let's make only the right side show up, and I'm specifically going to restrict it from 0 is less than x, which is less than, let's go with 10. So only one branch of that piece is showing up now that I have restricted it. And if I want to make that shaded, I would go greater than or equal to, and now we've got this funky little shape. Now, notice none of these things all at once look specifically good or interesting, but you guys will create something beautiful, I am sure. All right, let me real quick walk you through a couple pieces. So we've got an ellipse, we've got a hyperbola, we did shading. All right, then this last thing is making a picture, and I've done it for you because realistically I don't need you to do all the work here. But if you were to go into Desmos, type in all of these equations, you would see this cute little graph. It says I love you and I miss you. So hopefully that's a good little surprise for you. And then down below is your assignment, and I will give you more information. Well, this will be online, so you can check that out. Obviously, ask questions if you have them. Otherwise, maybe, well, hold on. All right, so I'm back here, and I just wanted to go through a little bit of the final project. So I want this to be fun and not too stressful. And so some of you I know are going to create something super crazy, and others of you, maybe it'll be more chill. I'm really okay with either option. So you are asked to make a picture. It's probably going to start and be very helpful if you sketch it out on a piece of paper, just so you can kind of get the general shapes, and then you can be like, oh, well, that piece of my drawing looks like it could be a parabola, or that piece looks like I could draw a circle. So consider doing that first. You need to have at least 10 equations. You can definitely have more. I am not saying you need to have more. There's not going to be any more points, but if you do not have 10, you will get points off. And you have to have at least 6 different graphs from the list below. So you can't just have 10 lines. You have to have 6 different graphs. Of these 6 different graphs, we need to have at least 3 different conic sections. Well, what are our conic sections? Remember, it's a parabola, hyperbola, an ellipse, and a circle. So basically, you need to have 3 out of those 4, and then a couple other equations. If you wanted square root, you're going to type SQRT to get a square root function. I need you to restrict the domain or the range for at least 4 of your equations, and at least one of them needs to be in inequality, so that would be like the shading piece. Creativity, of course, is a plus, but honestly, I'm not looking for you to be Picasso here. You can do something that represents something you're interested in. I don't know if any of you are interested in cars, but maybe. Music, sports, animals, whatever. You could do a logo. You could do a famous artwork or letters or words. Honestly, if you're looking for something that's not crazy, just do your name. You could just do a pattern or a colorful character. You can make a flower. It doesn't really matter, whatever is interesting to you. But here's my thing. Do not plagiarize, okay? I realize that this project is a project that a ton of people have done, so you can. Type in Desmos art into Google, and guess what? You're going to find a ton of really crazy things. Now, while these are all super beautiful and cool, first off, if you create something that has equations that you shouldn't necessarily know, I'm probably going to be a little suspicious. And if you create something that looks exactly like one of these, I am probably going to be very suspicious. I'm not an idiot, so please don't do that. Please just come up with something on your own. Make it unique. Doesn't have to be wild. That's what I'm looking for. All right. Once you have this, you can share the graph in the upper right-hand corner. This little guy you can share, and you can either share it as a link, you can export the image. Just make sure you have these formulas somewhere for me to look at. Over here in the top right, I think I should have mentioned this at the beginning, but creating an account is going to be the best way to make sure your work is saved often, so please do that. I think that's at the top of this page. Let's see. Yes, open an account to make sure you can save it. This is due. If you would like to type the equations in here or write them down, you can definitely do that. I'm fine with that. Otherwise, honestly, as long as you have a link to this and I can see all these equations, that is totally good enough. And you're asked to email it to me by Monday, May 18th at 11:59 p.m. I'm going to check to see if there's a place I can post it on my DSHA for you to upload it there, but I'm not sure at this point exactly. So for right now, just make sure you can at least share it with me, and I think that's what I got for you. So if there are questions about these, please let me know. Otherwise, good luck and have fun.